Okay, in this video episode, I'm going to show you how to apply a scale factor to an existing already drawn curve. As you can see, this curve is r to the power of x. We have some points marked out on it. 1, 2, 3, 4 key points marked out. Let me just read the question to you. We have the graph of y equals r to the x is shown. Transform and sketch y equals r to the power of x on 3. Now we're going to take it in two simple steps. The first thing is we're going to determine what the coefficient a is so we can find the scale factor. And the second thing is we're going to apply that scale factor to this curve and see how much further or closer it is to the y-axis or vice versa. So let's begin off here. Now we know y equals r to the x on 3. We want to put it in the form of y equals r to the power of a x, where a is that coefficient that helps us determine the scale factor. That coefficient is in this format. We have y equals function ax. That's the coefficient a we're looking for. Now that a works with horizontal dilations. And that a is going to help us a lot to determine the scale factor. How? We apply it and put it into this formula here. The scale factor is equal to 1 over a. It's the reciprocal because a is inversely proportional to the scale factor. So we're going to apply it to that second of all. And then once we have that, once we put it in there, we'll get the scale factor and apply it up there. So let's go ahead and do that. So we've got y equals r to the ax. Now if we look at the equivalency of these two guys, this one, it's the same as writing, you probably know this, r to the power of 1/3 x. I'm going to write it a bit different. Y equals r to the power 1/3 x. That means the same thing, because x over 3. We're going to look at the coefficient of x here. It looks like the coefficient is 1/3, and that's the a we're after, so they're equivalent, which means a is equal to 1/3. Now, a is 1/3, and we know for when a equals 1/3, when we got a value of a which is between 0 and 1, in there, we're going to tend to get what? It's going to be horizontally stretched, expanded further away from the y-axis and closer to the x-axis. So that's what that means. So we got our a. Now we're going to take that a, put it into this. Scale factor equals 1 on a. So scale factor, horizontal scale factor, is equal to 1 over a. And what's what a? It's 1/3. So 1/3 is the denominator. So the factor is equal to 1 over 1/3. 1/3 goes into 1 3 times. So it's going to be 3. So our factor, our horizontal scale factor, is 3. Okay, now I'm going to give you a shortcut on how to get that 3. And we're going to use a different formula. We're going to go straight to it. It's going to be real quick. You can get the scale factor straight out from this. When you look at, you got x, anything underneath the x is the factor. Just looking at it is the 3. Just looking at it like that. Why? We use the x factor formula. So that takes us directly to the scale factor without necessitating the need to find a, the coefficient. So all you do is what's underneath the x, that's the factor. Once underneath x, it's 3. So the factor is 3. That's a shortcut way. That's the way I prefer, but it's good to know both ways. All right, now that we have the factor, what does it mean? It means that the distance horizontal is expanded 3 times. 3 times, triple the amount of distance away from the y-axis, either way, from left to right along the x-plane. So what does that mean? We're going to apply this 3 to this existing graph. So we're going to go anything to the right of the graph, the distances will be tripled, and to the left will be tripled. Okay? On the horizontal plane only, not on the y-plane. Okay, let's work with the first point. The first point goes through the y-axis. What's the distance between this point and the y-axis? Well, it's on the y-axis, so you can't triple that, so it stays the same. So the new curve will be in the same spot. If I go up here to the second point here, the horizontal distance between the y-axis and that point is 1 unit. So that means we're going to triple that from the y-axis. So if that's 1 unit, I'm going to go 3 times away. So we start at the y-axis again, 1, 2, 3. The new point will be right there. That's the new point. So that's triple the distance. So 1 here, 3 away there. From the y-axis, not from this point. Let's go to the next point, up here on the same horizontal plane. Let's have a look. This is 1, 2. 2 units away from the y-axis horizontally. We're going to triple that. So that's 2. Now, triple of 2 is what? Is 6. So let's go 2, 4, 6. There we go. There's our new point. So it's been expanded and stretched out 3 times as wide away from the y-axis. Next point. We've got this point here. It's 1, 2, 3 units away. So we're going to triple that. 3 times 3 is 9. So we go 3, 6, 9. So that point's going to be right there. So that's been stretched out triple the distance, the scale factor of 3. Now let's look on the left-hand side because there's some stretching happening there. So on the left-hand side, the same thing happens. On the negative side here, it means we're going to triple the distance. Now it's pretty hard because this is pretty horizontal. So stretching something horizontal, you can't really see much. Like that, you can see a lot, but like this, you can't. But over here, we might be able to see a bit. Like for example, here, it's going to go, if I pick a point here and I triple the distance out, it's going to go out that way. So it looks like it's going to be a little bit on top here, and then it's going to merge. So it's going to be on top of the curve here. Then it's going to come out to this point right there. Then out to this point. And then it's going to come out to that point. Like that. So there you go. There's our new curve. This is y is equal to r to the power of x over 3. And what that means is the scale factor's on the denominator of 3. It's 3 times as wide, stretched outwards horizontally away from the y-axis. And there you go.